Good day. In this lecture, we go to chapter 3, operators and expressions. In C, there are 5 operators, arithmetic operators: addition, subtraction, multiplication, division, and modulus operator. A modulus operator is an integer remainder after an integer division, and the sign depends on the first sign of the first operand. For example, a modulus b, if a is negative, then the result is going to be a negative integer number. These operators require 2 numeric operands, one on the left and one on the right. For example, a plus b, so a and b are the numeric operands. And these are the rules. Integer gives integer, float and float give float, but mixed mode, for example, integer float or float integer, will give floating point. For example, a plus b, if a is float, b is integer, so the result is going to be float. Example 1. We have 2 integer variables, a and b, with initial values. The following operations will result in integer constants, because basically the operands are a and b are integers. So a plus b is integer 13, a minus b integer 7, a times b gives you integer 30. A divided by b. Remember the mixed mode rule above? So in this case, it's going to be 10 over 3. So you get intermediate result is 10.333 something. But the final result is going to be integer because a and b are integers. A modulus b is actually 3 divided by 3. 10 divided by 3. So 10 over 3 gives you a quotient of 3 and the remainder is 1. So the answer is integer 1. You can program all this as follows. Here, the format for these operations are %d, because the output is integer, and for integer the format is %d. So you get this output here from this program. Example 2, we have floating point variables v1 and v2 with initial values. Since we have v1 and v2 are floats, so the arithmetic operations will also result in floating point constants. So this is v1 plus v2, v1 minus v2, v1 times v2, v1 over v2. Of course, you can program this as follows. Why the format is %f? Because for floating point constant, the format is going to be %f. And in this case, %f is referred to, of course, free format for floating point constants, and it will return the answers to 6 decimal places as follows. Later on, when we go to formatting, we can see how we can adjust this formatting so that we can get, for example, how to get 14.5, 14.500 and so on in the next later chapters. Next, example 3. We have 2 character variables, C1 and C2, with initial values. The following arithmetic operations involving C1 and C2 will produce the following integer constants. You cannot add, for example, capital P and capital T, you get 164. It doesn't work that way because arithmetic operators, operands must be numbers. So in this case, character constants, they have ASCII values. So following this arithmetic operation, the ASCII values of the character constants are used. So C1 in this program, I print the ASCII value of C1 and C2. So C1, the ASCII value is 80, C2 is 84. That's why C1 plus C2 we get 164. In this line, C1 plus C2 plus C5. Sorry, C1 plus C2 plus 5. 5 is integer constant. So we're just adding 84 and 5. So we get 169. Here we are adding character constant 5 to C1 and C2. So character constant 5 has an ASCII value, which is, I print here, the ASCII value is 53. So here we are adding 80 plus 84 plus 53. So we get 217 for this statement. 3.2 unary operators. Unary operators act upon a single operand. We have unary minus. It's basically to give a number a minus sign. Don't confuse this with subtraction operator. We have the plus plus increment operator. Minus minus is decrement operator. Plus plus increases operand by 1. Minus minus decreases operand by 1. Size of returns size of operand in bytes, except size of character array will return the number of array element. This is the only exception. And finally, we have cast operator, which converts between integer and floating point constants. You can convert integer to float and vice versa, float to integer, using the cast operator, as the following example will show. So the compact operators plus plus I expanded. This is actually the true statement. It's actually I equal to I plus 1. The decrement operator minus minus j is actually j equal to j minus 1. Example. So here we have integer variables I, j, floating point variable x, character variable b, character array c, and integer array d. They all have initial values. Let's say printf plus plus I. Plus plus I is I equal to I plus 1. So when I print this, it will print the latest value of I is going to be 3. So you get 3 here. Second line, j plus plus. Here we are printing j first. That's why we get 3 there. After that, increment j by 1. That's why in the third line, I print j, I get 4, because this is the latest value of j. In this line, print of size of I. I is integer variable. Size of x is floating point variable, and size of integer and floating point variables will return the number of memory required to store the constants. So it's going to be 4 bytes for integer variable and also 4 bytes for any floating point variable. Next, we have printf size of b. This is the unary operator. Size of b. B is character constant. For character constant, the memory required is 1 byte. Size of c. C is a character array, so this is the only exception. Since C is a character array, size of will return the number of array elements. That's why it returns here 7. Because the number of array elements is going to be 6 plus 1, because this is string constant. Remember, at the end of string constants, we have /0, end of string marker. Here we have size of d. D is not a character array. It is an integer array here. Size 3. So it will return the number of bytes to store all these array elements. So it's going to be 3 elements of d times 4 bytes per integer or floating point element. So we have 12. And finally, we use the cast operator, float 5. Here we convert integer 5 to floating point constant 5.000. 6 decimal places because we use free format for f. Here we use the cast operator to convert floating point constant to integer constant. So 6.5 converted to integer constant, we get 6. And of course, you must use the correct format. Integer, %d. Of course, the result here is float, %f. Details on the formatting will come in the next chapter. 3.3 Relational and logical operators. In C, there are 4 relational operators. These are the symbols used: less than or equal to, greater than or equal to. For or operation is actually logical operation. Of course, true or true, you get true. True or false, you get true. False or true, you get true. Of course, true or true, you get true. Relational operators require 2 numeric operands, one on the left and one on the right of the operator. The outcome is going to be logical, true, represented by integer 1, and false, represented by integer 0. We also have 2 equality operators. This will compare operand on left and right of this operator. If the answer is true, you get 1. If the answer is false, you get 0. This is the not equal to operator. A not equal to B. If true, the answer is 1, true. Otherwise, it's 0, false. The outcome is logical, 0 or 1. In this example, we have 3 integer variables I, j, k with initial values. In the first operation, we compare using relational operator less than I less than j. You just substitute the values, so you get 1 less than 2, which is true. So the answer is 1. I plus j greater than or equal to. So we just plug in the values. So we get 3 plus 3 greater than, on the right, 3. K is 3. So you get, for this first test, the answer is going to be false. But still, there's the second one, or I plus j equals 3. So, or 3 equals 3, which is true. So the final operation is going to be false or true. False or true is true. This is basically Boolean logic. J plus k less than I plus 5. So plug in the values. So we get 5 less than 6. So the answer is true, 1. K is not equal to 3. So k is 3. 3 is not equal to 3. Of course, it's false. So the answer is 0. We compare this operand j has a value 2 equals, is it equal to 2? The answer is yes. So we get the final outcome is logical true, 1. Of course, we can program all this as follows and get all these answers here. These are logical values. Since logical values are integers, 0 or 1, you must use the correct format here. That's why it's %d. We also have logical operators. There are 2 of them: the AND operator and the OR operator. Logical operators require 2 logical operands, one on the left, one on the right. These are the rules. These are basically Boolean logic. True and true is true. True and false is false. False and true is false. False and false is of course false. And of course, for the OR operator, true or true is true. True or false is true. False or true is true. False or false is false. In the following example, we have integer variable I, floating point variable f, and character variable c with initial values. In these operations, which involve relational and logical operators, so we have this one is going to be plug in the values, it's going to be true, so you're going to get true and true, true. For the second operation, you get true or true, which is true. Third one, true and false, which come to false. And the last one, you're going to get this is going to be true, this is going to be false. So you get true or false is true. Of course, you can program all this in this C program. And remember, the number 0 has a logical value of 0. The rest of the numbers which are not 0 have logical value of 1. For example, I'm using the AND operator, 5n minus 7. This is actually this number, pure numbers. The logical value is going to be actually 1 and 1. Of course, the result is going to be logical 1, true. In this case, 4.5 is a pure number. 0, you don't have to convert to logical, it's already, logical value is 0. So it's going to be true or false. And the answer is going to be, of course, false. The OR operator, you get true. True or false is true. We have also assignment operators. This sign is known as the assignment operator. This is the syntax. Basically, expression on the right is assigned to identifier on the left. This can be simple variable or it can be array variable. Here we have integer constant tree. How do you read this? It's actually integer constant tree assigned to variable A. Variable y, whatever value here, is assigned to new variable x. A plus b is assigned to sum. In addition to this assignment operator, we also have the so-called 5 special assignment operators. These 5. This first one. Expression 1 plus equal expression 2. This is basically, you have to expand this into this form. This is actually expression 1 equals expression 1 plus expression 2. Expression 1 equals expression 1 minus expression 2. This one, expression 1 equals expression 1 times expression 2. Expression 1 equals expression 1 divided by expression 2. Expression 1 equals expression 1 modulus expression 2. Find the final values of k in this example. We have integer I equal to 5, k, another integer variable, has integer constant 4. We have these two statements. In the first one, expand into its full form, it's going to be I equals I plus 5. Plug in the values, so I is going to be 10. The answer is I equals to 10, just the latest value of I. Next one, we have k equals k times 3. Plug in the values, so you get 4 times 3, 12. So the answer is k equals 12. We also have the conditional operator. The syntax is expression 1, question mark, expression 2, full colon, expression 3. This is actually an alternative to the formal if-else statement, which we'll see later on in later chapters. So basically what happened is, if expression 1 is true, evaluate expression 2, replace expression 1 with the value of expression 2. Otherwise, if this is false, evaluate expression 3, and replace expression 1 with expression 3. Operator precedence. Operator precedence basically will dictate which operator has a higher priority. Of course, in this table, the higher in the table, the higher the priority. Within the same line, the priority is the same. For example, if I have two operators in the same expression, you can proceed with any operator first because they have the same priority. The association, for example here, for the plus operator, left to right means, for example, 4 plus 5 is from the left, 4 plus 5 is not 5 plus 4. So we see here the unary operators, unary minus, increment, decrement, the not operator operates on a logical operands. For example, not true is false, not false is true. Size of, and also the cast operator is a cast operator. They have the highest priority. As you go down, the priority gets lower. Of course, the lowest priority is going to be the assignment operators. The simple assignment operator and the special one, the 5-1 special assignment operators. In this example, find C and D. So we have 3 integer variables, A, B, C, D. Only A and B have initial values. And we want to evaluate what is the value of C and value of D. To evaluate C, you see here there are 3 operators: assignment, multiplication, addition. Using the precedence table, of course, between these 3, multiplication is the highest, followed by plus sign, the plus operator, and the assignment operator is going to be the last one. So we have C equals, we have to multiply first because it's the highest. 5 times 3, you get 15. After that, we are left with assignment and plus, but plus is higher. So 15 plus 3, you get 18. So the answer C is 18. In the second statement, D is 30 since this expression, this is the conditional operator. So this is true. 5 greater than 3, true. True, evaluate expression 2. So you get 30. Replace this with 30. So you get D equals 30. Only if this is false, D is going to be expression 3, which is 40. Final one, the final section, 3.7 library functions. Within the C compiler, we have the so-called built-in or intrinsic functions that the users can call at any time. For these are just some of the functions. For additional functions, see the textbook or you can Google the internet for C library functions. Here we have the trigonometric function. It can be sine, cosine, or tangent. Here we have cos. Inside the bracket, we have the argument. D are the argument. Arguments are floating point constants. And the outcome of this function are also logical, also. So the input arguments are floats, so the outcome are also float. So cosine of D returns the value of cosine D radians. ESP is E raised to the power D. Log is natural logarithm. Log 10 is log base 10. When you want to raise D1 to the power of D2, the function is PO. PO D1 comma D2. Square root basically returns the square root of this argument D. So in this example here, PO 10 is basically 10 power 2, 100. Cosine 0 radian is 1. Natural logarithm of 2, 0.7. Log 10, 100 is 2. Okay, 10 power 2 is 100. ESP 1.5 is actually E power 1.5, which is 4.48. Square root of 9, of course, is 3. And of course, you can program this as follows. So the output of these functions are floating point constant. That's why you have to use %f. That's the correct format. Thank you. In the next lecture, we'll go to the I/O, input and output.